Hello friends, you're welcome to my YouTube channel, Mathematics Made Easy. In today's video, we are to solve this simple problem. For A, A is a member of positive integers. Okay, let me read that. Sorry. So A is a member of the positive integers. Okay. So we have to prove that integral from 0 to 1 of natural log of 1 minus x over 1 plus x raised to the power of a over x dx. So that this will be equal to minus 1 raised to the power of a multiplied by a factorial multiplied by 2 minus 2 raised to the power of minus a multiplied by the zeta function of a plus 1. So that's what we want to prove. Okay, now let's start. Before that, don't forget to subscribe to my channel. Thank you. That's the way you support. You subscribe to my channel, like my videos, share, comment. Thank you for watching my videos. Okay, so let's move on to the problem. The integral is from 0 to 1 of the natural log raised to the power of a of 1 minus x over 1 plus x, then everything over x dx. So I'm going to make a substitution here to make the problem simple and easier. What substitution am I going to take here? So I'm just going to say that put 1 minus x, I'm talking about this, 1 minus x over 1 plus x to be y. Okay, so if I do that, I have to make x the subject of the formula to know what my x will be, because I want to be working in the y world now with respect to y, not respect to x again. So I have to know the value of x. Okay, what will be my x be if 1 minus x over 1 plus x is equal to y? So what you have to do is not something that is hard, it is common, your algebra. So you have to cross multiply, this will multiply this will multiply that. So if we do that, we are going to have 1 minus x is equal to y into bracket 1 plus x. So we have to expand this our right hand side. So if I do that, I'm going to have 1 minus x is equal to y plus yx. But don't forget, I want to make x the subject of the formula. So if you connect like terms, I'm going to have minus x minus yx equals y minus 1. Then I can factorize minus x out here. So that will be minus x into bracket 1 plus y is equal to y minus 1. Sorry. Then we are going to divide both sides by 1 plus 1. 1 plus y rather. Minus 1 plus y because of this minus here. So this is going to cancel each other. Then we can now see, that we can say x is equal to 1 minus y over 1 plus y. So the next step we have to take is to differentiate. We are working in the y world. Okay, so if I differentiate this, we are going to use our quotient rule to differentiate this quotient rule. So let me say u to be 1 minus x, and let me say v to be 1 plus x. Okay, for those that don't have the idea of differentiating, that's why we do that, because I don't supposed to do the differentiation, but so that we can remember how to differentiate a function like this, 1 minus y or 1 plus y, use quotient rule. Okay, so the next thing you have to do is to differentiate. So the u dx, we are working in y, so this is 1 minus y, 1 plus y, so this will be du dy will be minus 1, and the v dy will be 1. Then according to the law, or according to the quotient rule, we are going to have the x over the y, This is x and y, not y is equal to, you understand? If it is y is equal, that will be the y over the x. But since x is equal to 1 minus y over 1 plus y, that will be the x over the y. Okay, so the x over the y will equal to v, the u, the y, minus u, the v, the y, everything of this. Very easy problem. Okay, so let's just do that. So we are going to have we're going to have this. So we're going to have, if you apply those values that we found, so we are going to have the x, the y to be minus 2 over 1 plus y, everything squared. Okay, then I can say the x is equal to minus 2 over 1 plus y squared, the y. Very nice. Very nice. Okay, but don't forget the limit is going to change. Yeah, the limit is going to change. And why is the limit going to change? You know, said 1 minus x over 1 plus x is y. So at x equal to 1, we are going to have 1 minus 1 over 1 plus 1, and that is definitely 0. So because at x equal to 1, we have 0, then you substitute the second one. That would be 1 minus 0 over 1 plus 0, which is 1. So at x is equal to 0, we have 1. So the limit is going to change. Don't forget that. So if the limit change, our integral is going to become, that will be integral from 1 to 0. The natural log of y raised to the power of a over, x is now 1 minus y over 1 plus y. Then multiply by dx, which is minus 2, the y over 1 plus y squared. So we can see 1 plus y is going to cancel 1 out here. And we can bring this minus 2 out because it's a constant. So doing that, we are going to have a beautiful integral. Now, what's the beautiful integral? So that will be minus 2 integral from 0 to 1, sorry, from 1 to 0, from 1 to 0, okay, of natural log of y raised to the power of a over 1 minus y squared y. So according to what I taught you yesterday, so I can change this from 1 to 0 because of this negative sign. So this can be 2 multiplied by integral from 0 to 1 natural log of y raised to the power of a over 1 minus y squared the y. Okay, so very easy to solve now. So I can use summation, summation. Okay, because 1 over 1 minus y squared. So this is sum of n from 0 to infinity on y raised to the power of 2. Okay, so that is the sum I'm going to use in solving this particular problem. So from these parts, I can see this is 2 multiplied by the sum of n from 0 to infinity, integral from 0 to 1, then natural log of y raised to the power of a multiplied by y raised to the power of 2n the y. Beautiful, beautiful. So we have to solve this. We have to solve this. We have to solve this. So are we going to solve that? Let me quickly delete this so I can have more space. Thank you. Then to solve this problem, this is what we are left with, which is 2 multiplied by sum of n from 0 to infinity, integral from 0 to 1, y raised to the power of 2n multiplied by the natural log of y raised to the power of a the y. So I'm going to make a substitution. And what's the substitution I'm going to make? Like the substitution I made yesterday. So I'm just going to say it holds the natural log of y to be minus x then y will be equal to e raised to the power of minus x. Then the y will be equal to minus e raised to the power of minus x dx. And as usual, the limit is going to change. Okay, so at y equal 1, so that will be 0. At y equals 0, that will be infinity. Okay, but the limit is going to change, and because of this negative sign here, so you can just change it from 0 to infinity. You understand what I'm saying? So you can change from 0 to infinity, straightforward. Then after that, don't forget we are left with integral, 2 multiplied by sum of n from 0 to infinity, then integral from 0 to infinity e raised to the power of minus 2nx, then multiply by minus x raised to the power of a, then multiply by e raised to the power of minus x dx. Okay, so you apply the law of indices here, so that will be minus 1 raised to the power of a x raised to the power of a. So this will be 2 multiplied by minus 1 raised to the power of a, the sum of n from 0 to infinity of integral from 0 to infinity. Then these and these, if you apply the law of indices, that will be e raised to the power of minus x into bracket 2n plus 1 multiplied by x raised to the power of a dx. Wow, that is great. I'm sure you guys are following my solutions step by step, so don't let us miss any step unsolved. Okay, the next thing we have to do is to make another substitution, and what substitution we are going to make here. So here's the substitution we are going to make. So I can just say put x into bracket 2n plus 1 to be any letter you like. I'm using u, so I can now say x is equal to u over 2n plus 1, and then the x will be equal to the u over 2n plus 1. So I'm going to have 2 multiplied by minus 1 raised to the power of a multiplied by sum of n from 0 to infinity integral 0 to infinity of e raised to the power of minus u. The x is now u over 2n plus 1. That will be u over 2n plus 1 raised to the power of a, and then the x is now du over 2n plus 1. Okay, so very beautiful, very beautiful, very beautiful. Then I'm going to have 2 multiplied by minus 1 raised to the power of a, then multiply by the sum of n from 0 to infinity of 1 over 2n plus 1 raised to the power of a plus 1, then multiply by integral from 0 to infinity of e raised to the power of minus x raised to the power of a dx. So this is just x factorial. Don't forget, I solved that yesterday in my video. You can check my previous video on that. So this will be 2 multiplied by minus 1 raised to the power of a multiplied by the sum of n from 0 to infinity of a factorial over 2n plus 1 raised to the power of e plus 1. I can say we are through with the work, but not yet. We have to evaluate this fucking series here. And how are we going to evaluate the series? So we are left with the series that we are left with the series. Okay, so let me just write the series outside this. The series is I can write this as minus 1 raised to the power of a multiplied by a factorial multiplied by 2 multiplied by the sum n from 0 to infinity over 1 over 2n plus 1 raised to the power of a plus 1. Guys, we are good to go. Let us solve this series. Okay, so let me remind you guys something. If we have sum, your alternative series of n from 0 to infinity of minus 1 raised to the power of n a n. So this is going to give us 2 multiplied by sum of n from 0 to infinity a to n minus integral from n, minus sum of n from 0 to infinity of a n. Beautiful. So beautiful. So what do you think we can do here? Let me cancel this. Sorry. I have to cancel everything so that I can have more space. Yeah. So this is where we stopped. So I can make this the subject here. So if I make that the subject, so I can say 2 multiplied by the sum of n from 0 to infinity of a to n is equal to sum of n from 0 to infinity minus 1 raised to the power of an minus 1 raised to the power of n multiplied by an plus sum of n from 0 to infinity an. And then don't forget the series we want to evaluate. I'm using this to be the series 2 multiplied by sum of n from 0 to infinity of 1 over 2n plus 1 raised to the power a plus 1. I can say this is equal to sum of n from 0 to infinity of minus 1 raised to the power of n over n plus 1. Then plus sum of n from 0 to infinity of 1 over n plus 1 raised to the power a plus 1. A plus 1, sorry. And this one also is a plus 1. Okay? So, alright. So, let's solve the series one after the other. Sum of n from 0 to infinity of minus 1 raised to the power of n over n plus 1 raised to the power a plus 1. So this will just be the eta function of a plus 1. And the second one, which is sum of n from 0 to infinity of 1 over n plus 1 raised to the power a plus 1. That one is zeta function. Sorry. So that will be zeta function of a plus 1. Okay, guys, I want to remind us one rule. If you have gamma, eta function of let me use s, eta function of s. So eta function of s is the same thing as 1 minus 2 raised by 1 minus s multiplied by the zeta function of s. So therefore, eta function of a plus 1, I can say this is 1 minus 2 raised by 1 minus a plus 1 multiplied by the zeta function of a plus 1. So we can now say this is equal to 1 minus 2 raised to the power of minus a multiplied by the sum, multiplied by the zeta function of a plus 1. Then if we add it to the second sum, so we add that to the second sum, we are going to have 1 minus 2 raised by minus a, then multiply by the zeta function of a plus 1, then plus the zeta function of a plus 1. We can see that zeta function of a plus 1 is common, so you can factorize that out. I'm going to have zeta function of a plus 1 into brackets 1 plus 1 minus 2 into brackets minus a. That will be zeta of a plus 1 into bracket 2 minus 2 raised by 2 minus a. Okay, so but from our previous sum, don't forget we have minus 1 raised by a multiplied by a factorial there. Okay, so we can include that in our solution then to complete the work. Okay, so now putting that in our solution, that is multiplied by minus 1 raised by a multiplied by a factorial. I can now say, therefore, we have minus 1 raised to the power of a multiplied by a factorial multiply by 1, multiply by 2. Sorry, let me write that. Multiply by 2 minus 2 raised to the power of a. Sorry, raised to the power of a. Then multiply by the zeta function of a plus 1. Therefore, any integral you have like this, integral from 0 to 1 of natural log of 1 minus x over 1 plus x over x raised to the power of a dx is equal to this given answer. Note, a is a member of the set of positive integers. Alright guys, that's the end of our lecture for today. Don't forget to subscribe to my channel, please, like my videos and share. Thank you. See you in our next class.